Okay, let's try number 3 in your book. And number 3 says our differential equation is dx dt equals 1 minus x squared. And we're given an initial condition, so x of 0 equals 3, right? And I mean, this is really our x of t, or not the function, but we're going to find our solution x of t. So it says separate variables and use partial fractions, so that is partial fraction decomposition that you learned in calculus, to solve the initial value problem. So there's just a few problems in the beginning here, and then you do population models. But this is a very powerful technique that you're going to be using in chapter 2 and chapter 3 as well. So let's go ahead and just practice this, and it's a good review of what partial fractions is. So the directions say to separate variables first, which is fine. We're going to go ahead and do that. But what I want you to notice is this guy right here. This is a difference of two squares, right? That's a squared minus b squared. We know that from algebra. So dx dt is equal to 1 minus x times 1 plus x, right? That's what the difference of two squares is. If you go ahead and FOIL this guy out, you're going to get a squared minus b squared. Okay, so we wanted in this certain form, and now I'm going to cross multiply, so I'm going to get dx equals 1 minus x times 1 plus x dt. And again, here I'm going to separate the variables. So I'm going to divide everything by my factors here. So I can have dx, and again, we can write that here as well. And then we have dt on this side. So I have separated my variables. So I want to integrate. So we can do that, right? Okay, so we are going to use partial fractions with this expression, right? It's really 1 over this guy in order to make the integration easier. So I'm going to go ahead and, so we're going to wait for the integrals. Let me go ahead and write this out. Okay, so dx, right? And then this is going to be pretty easy. Okay, so I want to focus on this guy right here. We want to rewrite this expression as I want, so 1, okay, really want white here. Okay, 1 over, so I'm just going to write 1 minus x times the quantity 1 plus x. Okay, I want that to look like this. Right, because then we can use the natural logs when we integrate. So we just have to find our coefficients a and b. So again, if you remember, if you're not sure where I'm going with this, or where am I getting this from, where I'm getting this from, you can open your calculus book and you'll notice they'll talk about linear factors and integrating using partial fractions. Okay, so I want to find this a and b. So this next part is really just using algebra. I really want this, right? And we know we can just multiply, right? Least common multiple plus b times 1 minus x. Right, this guy needs this one, and this guy needs this one. Okay, so if you notice, I'm just writing the left-hand side. So notice the denominators are exactly the same. Therefore, the numerators must be the same if this equality, if we have an equation or proportion in this case. So I know that 1 equals a times 1 plus x plus b 1 minus x. So again, all this, put a little, I mean, I want to see this work, but this is all algebra right now. We're not doing any calculus, it's just algebra. So if x is equal to -1, right, we substitute our -1 into our equation, and we get 2b, right? If we input that negative 1, that's 1 plus 1. And then if you solve for b, right, you just get a half. And similarly, if x is 1, right, and I'm choosing 1 because 1 is going to make one expression go to 0. So then I get 2a, right, plus, well, our b is gone, b times 0, so we get equal 1, and then a is also 1/2. Okay, so now let's plug these guys back in here. And so remember what we have, right? This is what we have. So this 1/2, this a and b, I'm going to substitute and then integrate. Okay, so we can see everything here. So I'm going to rewrite, okay, so the integral of 1/2 right? That's my a over 1 minus x. Well, we can do this. Dx plus the integral of, again, it's the same, half over 1 plus x, or x plus 1. Dx equals the integral of dt. Okay, so the half is just a nice constant, so we can, I mean, technically factor that out, right? So if we take that out, we get the integral of 1 over 1 minus x. That's an integral. Dx plus the integral of 1 over x plus 1 dx. And, okay, we'll just keep writing this guy. Okay, so we have that half, and, I mean, we can multiply, I'm going to multiply 2 to both sides of the equation. It's just going to make life easier. So if I multiply by 2, again, this is tedious, but I do want to show all the steps to make sure we're all on the same page. Plus the integral of 1 over x plus 1 dx, right? And if I multiply by 2, it's just 2 times the integral of dt. So I have that. Okay, so I inserted, right, whoops, my a and my b. And now these guys are very familiar, right? I can integrate these guys. We know that's just a natural log. Now here, I want you to notice that 1 minus x, right? We can rewrite that as, if we factor out a negative, right? That's really x minus 1, right? If you distribute, you get negative x plus 1, or 1 minus x. And the reason I want you to rewrite it this way, or if you actually want to write it in, I'm going to bring that negative outside. And so I have 1 over x minus 1 dx. And okay, this guy is ready to integrate. So that's the natural log of x plus 1 equals, and we can integrate this guy already with our constant of integration. Okay, so the reason I wanted to wait for this one is because, okay, so when you integrate this guy, you should get the natural log of x minus 1, okay, plus, whoops, plus ln of x plus 1, okay, but remember we still have this, negative out here, right, so it's really a negative 1, equals 2t plus c. Okay, now I want that negative 1 gone, so if I just multiply negative 1 to both sides, I'm going to get ln of x minus 1, right? I'm distributing minus ln x minus 1, and then, oh, that's a c, so it should be negative 2t minus c. And this is great because we can use the quotient rule of logarithms here. That's just ln of x minus 1, and a small little error before right there. It should be a plus over x plus 1 negative 2t minus c. And let's see. Well, we know this guy is that's really log base e, right, from algebra. That's a 1, negative 2t plus c. And from the definition of logarithms, we know that the base raised to that side gives us that. So again, by algebra, e to the negative 2, not in blue, but e to the negative 2t plus c is equal to this rational expression. Okay, so let's see. We can use our initial condition right now to find c. So let's go ahead and do that. So we know x of 0 is 3. So we know that, right, this is really x of t, right? But we're doing x of 0. So that's really 3 minus 1 over 3 plus 1. This is 0, so this is nice. And this really means this or this. And that's just 1 times c. c is 2/4 or a half. Okay, perfect. We found our c. So let's plug this guy back in here. And I'm going to separate these guys. So we have e to the negative 2t, okay, times e to, well, e to the c, but it's really c. But we just found our c. Our c is a half. So that's our c equals x minus 1 over x plus 1. Okay, so let's cross multiply, right, this guy. We really have 1/2 e to the negative 2t times x plus 1 equals x minus 1. And let's multiply by 2 to make it look nicer. And if I multiply by 2 to the right, I get 2x minus 2. And again, our goal is to solve for x of t because that's going to be our solution to our differential equation. So we do a little bit more algebra, right? Distribute, distribute. Okay, so we have an e to the negative 2tx plus e to the negative 2t equals 2x minus 2. Wow, we're at 12 minutes. Okay, almost done. Let's see. I'm going to bring my x's over. So e to the negative 2tx minus 2x. And then I'm going to bring this guy to the right because it has no x. And actually, I'm going to write my 2 first. I'm going to have negative 2, and I'm subtracting this guy. And again, that's nothing right there. Erase that. And I can factor a greatest common factor. And I'm left with this expression. And we're almost done, right? Remember our x, this is really our x of t. So we know that's just negative 2 minus e to the negative 2t divided by e to the negative 2t minus 2. And that's your solution to the differential equation. You can simplify this a little bit more if you want. If you want to make the numbers positive, I mean, I can multiply everything by negative 1, top and bottom, right? So I get 2 plus e to the negative 2t over 2 minus e to the negative 2t. Right, this is your solution, right? To graph the solution sets, right, you're going to input that in your graphing calculator or computer, but make sure you indicate the particular solution, right? The x of 0 equals 3, where it crosses through that point. If you wanted to make e to the 2t positive, you can. I mean, you could multiply e to the 2t to this, and this, and then you'll be fine as well. If it's if they have that answer in the back of the book, it's very similar, or it's the same. Okay, that is number 3.